So for part two of chapter 5, we're going to be looking at still the biodiversity, the different biomes, but we're going to be focused more on sort of the threats to these locations and these different organisms, the biodiversity of the planet as a whole. And then we'll also see what's being done, what has been done, what can be done going forward to kind of help preserve this biodiversity, help preserve the different environments and the different organisms that inhabit those. And then just as a quick refresher, remember biodiversity, we're just looking at the different types of organisms that are going to live in the whatever that environment may be, depending on specifically what the biome is. So depending on specifically what type of environment that is, it'll lead to different organisms, different biodiversity. So again, deserts are going to lead to different types of organisms than the rainforest versus the tundra versus any other type of biome. The environment itself is going to lead to those adaptations, and that's going to give us this biodiversity. And that's true for the different plants, the different animals, different organisms of all types. And then with this diversity, we can think of it in a couple different types. So we can think of it in terms of genetic, species, or ecological. And then with the genetic diversity, we're thinking about the diversity within one species. And basically what we're thinking of is the variation that comes from sexual reproduction. And with this, we can look at it positively, we can look at it negatively as well. So from the negative perspective, the disadvantages, in order to obtain this genetic diversity, you will need sexual reproduction. So that's going to be a time-consuming process. So if you just think about humans, going to be pregnant for about 9 months typically. Can vary a little bit, of course, but about 9 months. So it's going to be a pretty long time. In terms of the different organisms, you may have seen, if you've ever watched Planet Earth, you've seen like that one bird's a pretty common one where it has the fancy colors and does all that different dancing and stuff like that. So it's going to take energy just in order to find a mate, in order to reproduce. And then with this, though, there's going to be advantages as well. And the main advantage is that the variation is going to actually help protect the population. So if we have variation within that population and a disease comes or just some sort of event occurs, if everything is exactly the same and that organism is susceptible to whatever that disease, whatever that change is going to be, it has the possibility to wipe out the entire population. But now if we have diversity, if we've got variation within those organisms, if a disease comes, it may take out all of the organisms with a certain characteristic, a certain trait, but the ones that are different, the variation may protect a different group of the population, allow that group to survive, and then continue to reproduce, continue to keep the species alive. And then you actually see this, that can actually be a disadvantage as well in certain cases. So if you see the variation in a population, that often occurs in pests. So if we spray pesticide on a crop, that can be similar to the introduction of a disease because that pesticide is designed to kill whatever that organism is going to be. But if there's variation within that organism, there may be a mutation that allows some of those organisms to survive. They're no longer going to be susceptible to what that pesticide is. That's going to allow them to reproduce. So from the human perspective, in that case, the variation would be a negative because it's going to allow that pest to continue staying alive, continue to reproduce, keep that population going. But in terms of that organism, the variation is what's actually going to save it. And then species diversity, now we're looking at sort of the community as a whole. How many different types of organisms do we have there? And that's going to be related to the final one, is ecological diversity, because the more species diversity, the more ecological diversity we have, just the more resilient these ecosystems are going to be, the more better able they're going to be to handle different stresses. And the reason for that is if we've got more species, if we've got more of this ecological diversity, so more niches, more trophic levels, just more things doing different processes, that's going to make the importance or the relative importance of one individual thing less. So it's going to be, it's going to allow the ecosystem as a whole to be more likely to survive. And one way you can think about that is if we have a whole, like a huge amount of biodiversity, and then we lose one portion of it, obviously that's still going to be bad, something that we want to try to avoid, something that we want to try to counteract. But if it happens and we have a large amount of biodiversity, the rest of the ecosystem will likely be able to kind of handle that loss. But now if we only have a little biodiversity, if we only have a few organisms present and we lose one of them, that's going to be a much larger relative change. It's going to be a much bigger deal overall, and that's going to have a greater consequence on the rest of them. So in terms of protection, whether we're looking at a single type of species, whether we're looking at a community as a whole, having that variation typically is going to be a good thing because it's going to help protect those communities. And then in addition to the biodiversity helping those communities, so we've also we've talked about it a little bit in terms of communities reestablishing themselves after disasters like wildfires, droughts, things that are basically going to come in and destroy an entire landscape. If that landscape's more biodiverse, it's more likely that something is going to survive whatever that disaster is, and then that something's going to help reestablish that environment. The less biodiversity we have, the less likely something is going to survive. And in that case, we would kind of just lose that entire community. And in addition to that, the biodiversity is also going to help maintain the populations of these different organisms. Because with the biodiversity, we're going to have kind of a natural checks and balances system in terms of making sure that no one organism is going to get too out of control, get too high of a population, and that would wind up having something else decrease in population. And then similarly, we'll see with pollinating species. So I'm going to talk about this later on in the course. But bees and things like that are extremely, extremely important. Not only are they an organism in and of itself, but they are extremely important in terms of pollinating other plants, and that helps the plant population reproduce, helps the plant stay biodiverse as well. And then just from sort of a human perspective, the biodiversity, of course, we use it to produce food, and a lot of times that biodiversity allows us to improve the food. So mixing different plants to get different like hybrids and things like that to produce better yielding crops, genetically modified organisms. Same thing with medicine. A lot of times we take different active ingredients, or even in the case of some pharmaceuticals, we'll take starting materials from different plants and then use that to start the reactions, whatever we're going to do to make the final product. And then there's cultural and aesthetic value as well. So things like fishing, hunting, camping, just being out in the environment, knowing that certain animals exist has value, knowing that there's polar bears in the Arctic, knowing that there's different types of rhinos and things like that in Africa has value. And then in addition to that, just seeing the beauty and the just sort of the vast differences just present in the world also has value. Because I think it would be pretty boring if you I personally love being outside, just going on hikes and things like that. I like seeing the different animals, the different flowers, stuff like that. So I think it would be pretty boring if we just went outside and everything was just the same. We've lost a lot of that biodiversity. And then in terms of the biodiversity, we can kind of see what are known as hotspots. And these are going to be areas where there are going to be a large number of endemic species. So remember, endemic just refers to species that are only going to be found in one specific location. So all of the different areas of red here are referring to areas that are going to have a high amount of those endemic species, a high amount of species that are going to be located just in that environment. So Madagascar, for example, off the coast of Africa, it's an isolated environment. That's why it's going to have a lot of endemic species. But then other places you're going to see these species pop up just because they're going to have a unique set of environmental conditions that's going to have them adapt just in only that location. But with this biodiversity, this is what we're going to be focused on for the first half of this, is going to be sort of the threats to it. And with the threats to biodiversity, what we're looking at is extinction. So just the elimination of that species or species. And with extinction, we should point out that it is a completely normal process. If you were able to look at all of the species throughout the entire history of the planet, you'd see that over 99% of them have gone extinct. So pretty much every species that has ever lived is currently extinct. And if we just look at a timeline of the previous 500 million years or so, we can see there's actually 5 mass extinctions. So you can see the y-axis here is just referring to the, like higher up we go, the more extinctions there are. And then the x-axis is just the time. So further to the left was longer ago. Right now is where we currently are. So you can see some projections for the future in terms of the extinction rate. And we can see what are known as the 5 mass extinctions. So we can see the big spikes in this graph where we see the extinction rate really increase drastically. And you can see at these different extinctions, the percentages of the species that were wiped out. So for the Permian extinction, 96% of all species were killed. So we can see that these were very extremely devastating events. And depending on which one we're looking at, they have different likely causes. So asteroid impact, volcanic activity, rapid global warming, things like that. And what I want to point out is if you look, rapid global cooling, rapid global cooling, rapid global warming, rapid global warming. Because within a lot of these periods, what we're going to see is the cycle of temperature change within the planet is going to play a large role in some of these extinctions. Because the temperature of the planet, the global average temperature, does change quite a bit over time. You can see, and it's going to have a couple of different factors. So the atmosphere, the presence of snow, the landscape just in general reflecting the sunlight and things like that, as well as volcanic activity and even asteroids, collisions and things. But what I want to point out is these changes in temperature were all natural in that they obviously didn't occur from man-made reasons. They weren't caused by human activity. And that's one of the main sort of attacks people have on global warming. We'll talk about it later on in the quarter. But people point to these previous extinctions caused by rapid global warming. And then they say that the current global warming we're experiencing is part of this cycle. It's part of just the natural heating and cooling of the planet, which again, is a natural process. You can see it just does go up and down. It does fluctuate over time. But with the global warming we're experiencing now, that is going to be a human-made global warming. That's going to be a human-made event. And what we're seeing due to that is a 6th mass extinction, what's known as the Anthropocene Extinction. And you can see based on the graph on the right, again, just the same idea as we move higher up into the y-axis, we're just seeing more and more of those species go extinct. we can see that this extinction is going to correlate with the Industrial Revolution. As we started to burn more of those fossil fuels, as we started to produce more carbon dioxide, as we started to warm the planet, we're going to start to see the, excuse me, we're going to start to see the biodiversity decrease, just because we're going to start to see more and more of these species go extinct. And again, it's going to be for, in this case, man-made reasons. The previous ones were all natural, obviously. This one is caused by the burning of fossil fuels, as well as a whole bunch of different reasons. These are going to have connections between them. So climate change itself is going to cause habitat destruction. Pollution is going to cause habitat destruction. Over-harvesting can cause habitat destruction. Population growth can cause habitat destruction. So when we're looking at this sixth mass extinction, what we're really going to be focused on is habitat destruction, but we're also going to be focused on how sort of these different factors also lead into that. So with this, again, just make sure you're kind of focused on habitat destruction overall, and then we'll see sort of how these different pieces relate to that. And the reason we're going to focus on habitat destruction is because, one, the other factors often lead to habitat destruction, but also because, two, habitat destruction is just going to be the biggest threat to biodiversity, because this habitat destruction is simply just destroying where these organisms live. And then if the home of these organisms is no longer there, they're going to have to move somewhere new. They're going to have to move to a new environment. They're going to have to move to a new community, where they may no longer be able to survive just because of the adaptations of the new environment that they need. They're not going to have those. They're not going to be adapted for that new environment potentially. Or if it's a similar sort of environment in terms of how it looks, there may be new predators, there may be diseases that they're not adapted for. So there can be a whole bunch of different things that's going to ultimately just lead to them not surviving. Even one thing that I think of often when I hear habitat destruction is back home in New York. I lived in a smaller city, but there was some woods behind my house. And then there was woods sort of around our neighborhood as well. What they've recently started to do is clear a lot of that wood so that they can build apartment complexes and things like that, because a lot of people from New York City are moving out of the city to try to find cheaper places to live. And then in this process, when they're clearing those woods, they're destroying the habitat of, there's not a ton of bears there, but there are a couple bears, but there's a whole bunch of deer and other organisms. So what they're seeing now is a whole bunch of deer being hit on the roads, because now those deer are venturing to new locations to try to find food. So they have to cross the road more often. They're going to get hit more often. The same things with bears as well. They're seeing more interaction with bears and humans. So they're seeing bears go into trash, bears going right up to people's houses and things like that. Because one, their habitat's being destroyed, but two, also as humans kind of expand into this environment, now those organisms are becoming more familiar with humans, so they're becoming more comfortable with humans. So now they feel more comfortable just actually walking up into their properties, going through their trash, and trying to find food that way. But in addition to this biodiversity, and that's not, of course, unique to my hometown, that occurs in a whole bunch of different locations. And we see similar things on an even larger scale in the Amazon rainforest, which we'll talk about, which we already talked about a little bit as well. We'll also talk about the destruction of the coral reef. So since 1950s, since the 1950s, over 50% of coral reefs on the planet have been lost. And then I already talked about it a little bit, but just the Midwestern United States, that was once that temperate grassland. A lot of that grassland has been replaced with agriculture. And then doing that, we lose a whole bunch of biodiversity, because now we're pretty much just planting one or a couple of crops in that area, rather than having the entire biodiversity that would naturally be present, all of those different organisms that would naturally live there. Now we're going to have just a very select few. And then in addition to that, just a couple of generic examples before we look at some specific ones. Anytime we're mining, what we're going to be doing is removing the top of that land. We're going to be releasing some toxic chemicals. So a lot of times when mining occurs, the toxic chemicals can actually leak out, get into water, and then cause damage on the surrounding ecosystem. Excuse me. Dams are another example. And with these, we can even think about these as beneficial processes to humans, but that are negatively impacting the environment. Because with mining, we're going to be taking resources from the earth for whether it's metal or oil, whatever, I don't know, whatever that exact purpose is going to be. With dams, we're doing it to obtain a reservoir, usually something that we can use for drinking water, or maybe agriculture as well if we need to use it for irrigation. But when we create a dam, we're going to be flooding entire ecosystems that are no longer going to be able to survive there. It will create different ecosystems over time, potentially, depending on exactly how it's done. But then with fishing as well, in addition to the exact methods they use, sometimes they use dynamite, sometimes they use cyanide to kind of kill the fish, or kind of get it to sleep almost, but it often kills the fish, and that also often impacts the coral reef as well. But with fishing, whoops, let me just go to this one. There's a process known as trawling, which essentially, as you can see here, is just you've got the boat pulling just a giant net along the bottom of the ocean. And what that's going to do is it's going to, you can see here, targeting rockfish, California halibut, Dover sole, Pacific cod, and lingcod. So it's just trying to get those fish specifically. But this isn't going to be a targeted practice. It's just going to come through, sweep along the bottom. And then as you can see here, just catch everything that's in that, catch everything in the bottom. It's going to destroy that entire ecosystem. So that's going to be an unsustainable practice, just like the dynamite or the cyanide methods are. And then just a few other ones. So the estuaries, talked about those a little bit in the first part of this chapter. Extremely important, extremely biodiverse, because we've got the mixture of salt and fresh water. We've got high nutrient levels. And estuaries were often present along much of the eastern seaboard. But once humans, or once the Industrial Revolution, once Europeans really started to settle in America, because of sewage and other contaminants just running off or intentionally being dumped into the water, those contaminants ultimately led to the destruction, the devastation of those estuary communities. So that's why there's no longer those vibrant ecosystems in places like New York City, and other main cities along the eastern coast. With the wetlands we talked about as well in the first part of that chapter, they help protect a lot of the endangered species. But with these wetlands, they're valuable land in terms of that they can be used for other purposes, something that can make people more money. So a lot of times these wetlands are going to be drained of the moisture, or they'll just be filled in, just so that the land can be converted into some other use. So we're destroying the wetlands for whatever that purpose may be. And then a similar process occurs with the mangrove trees. So these are present a lot in Asian countries. And the mangrove trees help provide structure. They help provide nutrients and things like that for the ecosystem. There's actually going to be, these are also along like the coasts, but these are also being destroyed for the purpose of farming, of shrimp and fish, so seafood, timber production, and then just some other human activities. So they're being removed so humans can build in that area, or they're being destroyed just because of the dumping of sewage and other waste products. And then the Amazon rainforest specifically, we've talked about. With this, again, the deforestation, you can see a picture on the bottom here. The reason for it could be logging, so they could be just removing the wood for whatever purpose they're going to use that wood for. They may be clearing it to grow food for people in that area. It may be removed just because of fires, developments of building on it. But whatever the reason is, This deforestation is going to be very problematic just because these areas are extremely, extremely biodiverse, probably the most biodiverse terrestrial biomes on the planet. And with these, once we remove the forest, it's going to be very difficult to get back because, like we said in the first part of this chapter, the rainforests are unique in that the nutrients are located in the organisms rather than the soil itself. So now if you look at these two pictures from 2009 versus 2019, the nutrients are going to be in the trees, they're going to be in the different organisms here. But now when we no longer have those trees, we no longer have those other organisms, we're no longer going to have that nutrient present. So if we want to try to reestablish this forest, it's going to be extremely difficult just because we're not going to have the nutrients necessary in order to do it. And then currently the rainforest has been deforested about a little under 20%. I think it's 17% or 18%. And what they expect is at about 20 to 25%, so not very much more. They expect to hit a tipping point where the water cycle in this area is going to be thrown off. And it's essentially going to lead to sort of a desertification of this area. And in that case, what's going to occur is even more deforestation, just because now there won't be enough water to support the trees that are still there. And that's going to lead to more biodiversity loss. But on a larger scale, that's also going to lead to increased global warming, because in addition to the forest being able to essentially remove some of that carbon dioxide from the air, this will also increase the temperature just from the lack of sunlight being absorbed by these plants. The bare soil typically is going to be a warmer environment than vegetation. So when we have more of this land exposed, that's also going to increase global warming. So we're just going to see a couple different positive feedback loops here. And I'm saying positive in the sense that it's going to reinforce that same change. So deforestation is ultimately going to lead to more deforestation. It's not positive, obviously, in the sense of being something we want. It's positive in the sense that the change itself is going to lead to more of that change. If it was a negative feedback loop, some of the deforestation wouldn't lead to more, it would lead to less. But in this case, since deforestation is going to circle back into more deforestation, that's why we're going to call it a positive loop, positive feedback loop. And then with this climate change, just in general, what we're going to see is as the temperature increases, we're going to see more and more of this habitat destruction. We're going to see this take place pretty much everywhere. So in the United States, we've seen increased wildfires. Obviously, that's going to destroy the ecosystems just by burning through everything. Depending on the specific environment prior to the fire, some may be more resilient, some may come back quicker after the fire is put out or is over. But it's still going to be a destructive event. And we're going to see that occur more and more often. So we're going to see more and more of the biodiversity loss through that. Because as those areas are devastated, the organisms living there, the plants, a lot of them are just going to die. Some of them, again, may be able to sort of regenerate and reestablish that area. But in terms of the animals, as that fire is coming through, they're going to have to scatter to new environments. Their homes are going to be essentially burned. And then as they move to those new environments, again, just like with any habitat destruction, they may no longer be adapted for that environment, or they may just be a predator, a disease that's present in that environment that's just going to come through and wipe them out. So that's why the habitat destruction is always going to be such a huge concern. And then in addition to the wildfires, what we're seeing in the polar regions is the melting of ice and snow. And obviously that's problematic for things like polar bears, things that rely on sort of moving along on the ice and snow. And then as that occurs, the biodiversity is going to be lost there just because there's not going to be as much land. Not all of those organisms are going to be able to survive in the water. And that's going to be another kind of positive feedback loop in the sense that the loss of some of those organisms is going to lead to the loss of more of them. Because if we lose the food for polar bears, we're then also going to lose polar bears themselves eventually. And then with this, as the ice and snow melts, we can also think about the sea level rising. That's going to impact coastal communities. That's going to lead to increased flooding. And just in general, we're going to see that the climate change is going to just lead to more extreme weather events. So we're going to see more hurricanes, we're going to see more tornadoes, and we're going to see stronger versions of those type of events. And then one other thing related to this is going to be the acidification of the ocean, and that's going to impact the destruction of coral reefs. So coral reefs in general, you can see on the image here, on the left-hand side, they're usually, when they're healthy, they're going to be kind of those vibrant colors. So you may have seen pictures of them from like Australia and things like that. They usually have those bright colors. They usually have a whole bunch of different fish and things like that swimming around them. Because when they're healthy, they're going to be very, very biodiverse areas. Because the reef itself needs to grow in warm, clear, and clean water. So it's going to promote other diverse organisms being present. But through a whole bunch of different activities, we can wind up with just reef looking like this, essentially dead coral reef. And that can occur from runoff from the land, even if it's good nutrients. If there's too much of them, that's going to promote algae growth. And then we'll essentially just wind up with a layer of algae on the top that's preventing the sunlight from getting to the coral reef. But also, like I said, there's fishing practices like dynamite and cyanide, where the swimmer, I don't know if I put one in here. Yeah, I didn't put one in. But there's a picture in the textbook with a swimmer, and he's got kind of just like a squirt gun almost of cyanide, comes in and sprays the cyanide. It stuns the organism and allows them to then take the organism out of the water, but it also often kills the organism, often kills the coral reef. Invasive species, we'll see those just in general in a little bit. But then diseases and changes in temperature can negatively impact these as well. So with the changes in temperature, global warming is going to increase the average temperature of the earth. It's going to also increase the average temperature of the water as well. So that can be a negative impact of the coral reef. And then when the reef is stressed because of any of those reasons, what you will see is it loses the vibrant color, becomes this white, it's called bleached version of coral. And when this occurs, it's just going to be more vulnerable to different diseases and things like that. And it also lost the algae on it, so it lost its main source of food there. But with the coral reefs, the way we're going to connect this back to global warming is through the acidification of the ocean. And we can kind of see what's going on in this process by looking at the image here. So whenever we burn fossil fuels, whether it's through the exhaust in our car, the smokestacks at power plants, we're releasing carbon dioxide into the atmosphere. And again, that's the driving force for global warming. That's why we're seeing the average global temperature increase so drastically, is because we're burning so many of these fossil fuels, and we have been for so long. And as we do that, the concentration in the air is going to increase. So we're going to get more and more of that carbon dioxide in the air. What the ocean actually serves as, though, is a source, or serves as a sink, I should say, for carbon dioxide. And a sink in terms of environmental chemistry is just going to be a sort of a location where the pollutant or whatever that substance is just basically going to collect. So in this case, the carbon dioxide, to an extent, is going to collect in the ocean. And in that sense, the ocean actually serves as sort of a barrier against global warming. It helps protect us against global warming to a degree, because it helps remove some of that carbon dioxide from the air. We'll see that there's technology currently being developed and has been developed that they use in these smokestacks that tries to capture the carbon dioxide before it even reaches the atmosphere. But once we do have it in the atmosphere, some of it is going to make its way into the ocean. And when this process occurs, it's going to dissolve in the water, and it's going to dissolve in the water in a way that's going to release a hydrogen ion, so this H+. This H+ is going to be characteristic of acids, and that's why we're going to call this ocean acidification. when this carbon dioxide dissolves in water, it's just going to make the ocean more acidic. And then with the coral reef itself, just to, before we get too far in this, if you look at the bottom here, it says coral. That's because this compound, CaCO3, that's going to be calcium carbonate. This is going to be what actually sort of makes up the skeleton of coral reef, and the same thing with other similar types of organisms. So I think mollusks are another one. But with this compound, it doesn't just exist as that form. Since these coral reef are in water, it's going to exist in sort of an equilibrium. It's going to exist in a balance. So the calcium carbonate is also going to be in the form of just these two ions. So it's going to be a calcium ion and a carbonate ion. But what's going to happen is once we dissolve that carbon dioxide, once we make that acid more acidic, the acidic proton, that H+, is going to react with some of that carbonate ion. It's going to decrease the amount of carbonate ion we have, which is essentially going to throw off this balance. So within the coral reef or within the mollusks, what's going to happen is some of this calcium carbonate that's making up its skeleton is essentially going to dissolve into the water to give us more of this carbonate. So it's going to be losing some of its skeleton. Essentially, it's going to become weaker. And that's why we're seeing some of the coral reef start to essentially die, is because this process of acidification is removing the calcium carbonate from its skeleton. And then what we can see here on this graph, if you're wondering, this is just showing the calcium or the carbon dioxide concentration in the air on the x-axis. So it's increasing as we move right. And as we increase that concentration, we can see we're moving down on the y-axis. This is just the amount of carbonate in the water. So as this goes down, we're going to lose the calcium carbonate in the coral because it's going to essentially try to replace it. And that's why these coral reef are being negatively impacted by the global warming, by this ocean acidification. It's essentially just removing the calcium carbonate from the coral. It's essentially just weakening that skeleton. And then in addition to that, acid rain isn't as big of an issue with the oceans, just because the oceans are so large. There's so much water in the ocean that if rain occurs, it's going to be essentially diluted. So it's just not going to have as large of an effect. But then when we look at rivers and lakes and other smaller bodies of water, they're going to be more impacted by acid rain. And we can actually see a somewhat similar process occur. Not exactly the same, but just so we can see sort of habitat destruction again. Because remember, with the coral reef, the reef serves as a shelter for a whole bunch of different organisms. So as that reef starts to die, we're just going to lose a whole bunch of biodiversity. Similarly with the acid rain, if we think about just a lake, if acid rain then comes, dumps that acid rain into the lake, it's going to acidify some of that water. And as that water becomes more acidic, it's just going to be a less habitable environment for anything that's living in it, whether it's a plant or a fish, an amphibian, a reptile, whatever it may be. It's just not going to be something that can survive as easily, at least. And then what we can also see is with this process on terrestrial plants, so sometimes trees and other plants are going to be killed or just at least harmed by this acid rain. Typically, acid rain isn't extremely acidic. Usually it's only mildly acidic, so it may just kind of sting if you got it on you at its worst. But with the plants and other organisms, they're going to be more susceptible to it. So they will actually potentially die or be more harmed than we would. And then in addition to just the natural environment, if you've ever seen certain statues or certain buildings that kind of get worn down, one of the reasons for that may be if it's marble, it's going to be susceptible to the acid rain. So the acid rain will actually kind of just eat away at it. So if you ever see a building or a statue that's kind of really worn down, it may just be natural erosion from other sources, or it could be just actually acid rain in that case. And then in addition to just habitat destruct, like complete habitat destruction, there's also fragmentation, which is sort of a smaller scale. And we can use this image to kind of walk through it. So on the we're looking at the 30% habitat, the one that I'm currently circling, the furthest to the left, as going to be kind of the original environment. And we can look at the green circles as sort of representing the areas where these population live. So we had 4 different population. What we want to think about is the distance between these population and just the overall size that these habitats are taken up, and sort of how that's going to affect the biodiversity in that area. And when we do this, the smaller the habitat, the less biodiverse it's going to be overall, just because it's going to be small in general. We're saying, by the way, in general, the smaller it's going to be, the less biodiverse. And then also the further it is away from other habitats, the less biodiverse it's going to be as well. So for the first one, this is going to be habitat loss, just because if you look, the habitats themselves are becoming smaller. So we're going from 30% of this area being habitat to just 10%. The reason this is going to be problematic is because this is actually just habitat loss. We're reducing the area in which these can survive. So we're just going to have less resources. We're going to have more competition. It's just going to be a worse environment for whatever this organism is. And then with habitat fragmentation, you can see 30% habitat versus 30% habitat. So in terms of the overall area that these organisms have to live in, it's the same. But what can be problematic about this is now that these populations are smaller, they're going to be more susceptible to just being wiped out, just because a smaller population is just easier to lose all of them, either through some sort of disease or disaster, or just through not having a viable enough population. But also one thing to point out here is the closer these habitats are, the easier it's going to be for them to kind of interact, and that'll help preserve the population, help protect the population as well. And what this idea ultimately led to is sort of how we can understand how these different how we can kind of balance protecting some of these organisms. And in terms of balance, what I'm thinking of is the extinction of different organisms, which is again a natural process, and then balancing that versus the rate of immigration from new species. So just some sort of new species being introduced into that environment. And this could occur from like humans bringing in that species intentionally or unintentionally, or it could just be from the natural movement of that species from one habitat to another. But just to kind of look at this quickly, rate of immigration. And we're thinking about this in terms of island biogeography, because we're thinking about this in terms of if we had an island, what type of species would we have there? And what they normally see is the smaller the island, the further away from it is from other islands, the least biodiverse it's going to be. And that's what we're seeing on this graph. If we look number of species, 0 to many, A has the fewest because it's the smallest island. It can support the least amount of organisms, and it's the furthest from the mainland. So it's going to be the most difficult for any organisms to get to, especially a terrestrial organism. A bird may be able to fly to it, but something that lives on land isn't really going to make its way to it at all. So with the case of these small islands that are far away from everything, the reason we typically don't see much biodiversity there is because it's going to be difficult for anything new to get there. So as we see those populations that are already present kind of change, one of them may get out of control, one of them may devastate the other, and then there's really going to be nothing to help kind of balance that out. Whereas if we look at the other extreme, if we go to D now, if we look at close to the mainland and it's a larger island, now we're going to have more species present because the island itself, the larger it is in general, it's going to be able to support more organisms. And then if it's closer to the mainland or if it's closer to other islands, it's going to be easier for the organisms to move between them. We're going to get more biodiversity that way. We're going to be able to protect those species better now that we have better biodiversity. We have more biodiversity. And that's why we're going to see the number of species increase. And the reason we call this island biogeography is because the thought idea for it is in terms of these different islands. Again, the closer the island, the larger it is, the more biodiversity we're going to have. So the more species we're going to have, because we're going to be able to better protect all of those species. Whereas a small island has less resources. If it's far away from the mainland or other islands, we're not going to have a whole bunch of immigration there. So we're going to lose those species much quicker. We're not going to be able to have other species kind of take their place. So that's where we're going to have less overall. And then, like I said, with the immigration piece here, it could be humans intentionally introducing some organism. It could be unintentional in the sense that sometimes just natural transport, so just moving from one place to another. Sometimes you'll accidentally just bring along some organism that you didn't even intend to. Maybe if it's just something that's sort of sticking along on a boat. A lot of times shipping things introduces new organisms. And then with these organisms, when they're introduced to a new environment, and that environment doesn't contain anything that's going to limit it, so there's no natural predator, there's no diseases that are going to kill it, there's no limitation on the resources it needs, so everything in terms of food, water, shelter, any of those other potential resources are all available and in large quantities. We're going to refer to these as invasive species because there's nothing that's going to be able to control them, and they're just going to essentially continue to reproduce until they change or disrupt that ecosystem pretty drastically. And again, sometimes it's going to be intentional, sometimes it can work out well, other times it can be accidental and not have too much of a consequence, but sometimes even if it is intentional, it can be hugely negative. And one example of that is going to be the cane toad. So in Australia, they were having a problem on their sugarcane fields with a cane beetle. And that was destroying their crops. And what they wanted to do was take care of that beetle without using pesticides. And again, we'll cover pesticides in a later chapter, but essentially pesticides can have negative consequences if they get to non-target areas or non-target organisms. So if they got to anything that wasn't the cane beetle, it could negatively impact whatever that thing or whatever that location is. So what they decided to do instead was introduce about 100 of these cane toads, which were supposed to just come in, eat the beetles, and then the beetle would be no problem. And ultimately what happened was the cane toad wound up reproducing uncontrolled, and now in Australia there are over 1.5 billion of these things. So with these invasive species, in this case they purposely introduced it, but then it got out of control, and now they can't really, and now it's at 1.5 billion, so now it really got out of hand quick. Other ones are less intentional or completely unintentional. So the American chestnut was a tree in the Appalachian Mountains, and it was used for a lot of different purposes. You can see a picture here, so a very, very large tree. You can think about it in terms of the biodiversity of it, just the habitats it can provide within the tree itself, the root system, the shade underneath, as well as any of the food it could provide from leaves, and then the nuts of this tree were very nutritious too. So it's a very useful, very beneficial tree. And at the turn of the 19th into the 20th century, it was not surprisingly used a lot. They wanted to plant it a lot. So what they did in the Appalachian Mountains was they received a shipment of nursery trees from Asia. And then these were trees that they were just going to plant there and start growing. But these trees were infected with a disease that within the next couple of decades pretty much just completely wiped out this American chestnut tree. I believe there are a few that may still be hanging around somewhere, But I think those are also kind of a hybrid. I think they've been mixed with another type of tree. So I don't know if it's exactly the same species of tree. And then similarly, the water hyacinth is just a free floating plant. So it just kind of hangs out on top of the water, sort of like a plant would just on soil. It's got the roots system sort of just floating underneath it. And then these plants spread very, very quickly. And what they can actually do is take over an entire like lake or something like that. Because what you can kind of see already going on here is when they invade whatever that body of water is going to be, they're going to spread quickly. They can double in less than 2 weeks the amount of area that they're taking up. So they can spread extremely quickly. And when they do that, they're going to spread across the top of the entire surface of that water. That's going to prevent sunlight from getting into the water. That's going to prevent oxygen from getting into the water as well. So that's going to negatively impact any of the fish living there because it won't be as favorable as an environment. The same thing with plants underneath. They're no longer going to be able to perform photosynthesis. It's going to make it worse overall for everything else. And we're going to see just in general the biodiversity decrease whenever we have the water hyacinth kind of taking over that ecosystem. And then with this, you'll see similar things, I should say, with terrestrial weeds as well. So a lot of times the reason weeds can cause problems is because they're going to take over the landscape. They're going to take all of the nutrients in that area, and then the other plants aren't going to be able to get the nutrients they need in order to survive and grow, and they're ultimately just going to die. Same thing we see in the lakes and stuff with the hyacinth here. Another example is the zebra mussel in the Great Lakes near the East Coast and the Midwest. So these mussels basically just similar to the hyacinth, almost just basically cover up mollusks, cover up the spawning beds of fish where they breed. So it prevents the organisms from reproducing and surviving successfully. They can also just get into pipes and drains and just cause a nuisance that way. So they're environmentally quite a nuisance. And then in order to remove them, and then this is government costs as well as just private costs, spends over $400 million a year just dealing with these. With these, I should say they do help the quality of the water in terms of the clearness of it, but it's definitely not worth all of the other issues here. And then with these, I believe they were also introduced with I think it was a shipping sort of instance where they just, while products were being moved, while boats were moving, they just traveled that way. And then this one, I actually just saw an article about this a couple weeks ago. This is the Joro spider. It's a spider from Asia. And this one, again, thankfully, this one looks a lot worse than it actually is. It is a harmless spider. But this cat came into the southeastern United States, I believe started with Georgia, from Asia, just in shipping containers. And then now this spider, they expect to kind of just spread throughout the entire eastern coast. Again, it's harmless, but it is, I personally am not a fan of spiders. And if I saw this one, I would not have a good time. But again, this is just an example of an invasive species because it was introduced to a new environment. And then there was no natural predators, no diseases, no limitations on the resources it needed. So it's just able to pretty much infinitely reproduce. And that's why they expect it to just be able to take over the entire eastern coast, essentially, just because there's nothing there to limit that population. And then with the invasive species, so this one, I don't know if it would really cause habitat destruction. I would assume it would, just because it's going to be, at least for some sort of organism, it's probably going to take their food supply. But we can see with the water hyacinth, it blocks out the sunlight, the oxygen from the other plants and organisms in the lake. The fungus that killed this tree obviously just wiped out the tree. So we can see that those examples of invasive species are decreasing biodiversity. What we also see is pollution can do the same thing because these toxic pollutants, these different contaminants that are getting into the environment, when they're present in the environment, when they come in contact with these different organisms, they're just going to have negative consequences, and they're ultimately just going to lead to different diseases, different health outcomes, and just ultimately death. One example, the Hudson River back in New York, so pretty close to where I grew up. The company General Electric dumped a whole bunch of polychlorinated biphenyls. So they're good at heat exchange and sort of keeping electrical boxes from overheating and things like that. But the PCBs collect in the environment. They don't really break down at all. So General Electric dumped a whole bunch of them into the Hudson. And then these are toxic, so they wound up killing a bunch of the fish life, and they also accumulate higher up in the food web. So higher trophic levels just wound up having higher and higher concentrations of these chemicals, and it just led to the loss of a lot of different animals and plants and things like that. Similarly, DDT was purposely sprayed because it helped with the spread of malaria and preventing that. Killed a bunch of insects, but DDT is a forever chemical, so it doesn't break down at all. It hasn't been sprayed in the United States in an extremely long time, but you can still find it present in a lot of different environments just because it is so persistent. It doesn't break down very easily. And then DDT actually resulted in, and similar chemicals resulted in a lot of birds wound up dying just because they weren't able to produce. It wound up affecting the reproduction, and ultimately the offspring weren't able to survive. There was problems with the eggs and a couple other things. But this occurred again because the chemicals are present in the environment. The birds then are exposed to those chemicals. They eat other organisms that were exposed to those chemicals, so it kind of just builds up even more. And then these chemicals is one of the reasons we ultimately led to the establishment of the Environmental Protection Agency. So Silent Spring, one of the reasons for that name, and that was the book written by Rachel Carson, which kind of got helped get the public interested in this. The reason it's called Silent Spring is because this chemical did kill so many birds, so they just didn't notice the normal birds singing in the spring. Made them realize that there was some sort of environmental issue going on. And then, like I said, these chemicals often accumulate higher up in the food web at higher trophic levels because they're going to be present in the lower organisms, which are then going to be eaten by the carnivores, the higher trophic level organisms. And then those chemicals are just going to remain in that animal, just because, like the environment, they're not going to be broken down. And then I think this is, okay, so we got two more pieces to look at in terms of the threats, and then we'll see sort of what has been done in the past to kind of combat some of these issues, what has been or what can be done in the future to help this. But another example of a threat to biodiversity is going to be this overharvesting. And this picture here is what I was referring to previously with the cyanide fishing. This person fishing, you can't really see it because it's a little blurry, but they're spraying cyanide onto the whatever that organism is going to be to basically stun that organism. But in this process, the cyanide is also going to kill the coral reef. So it's an extremely unsustainable practice. And then we see something similar with dynamite. They blow up different areas to essentially kill the fish. It's going to destroy that area as well as leaving toxic residues. But in terms of overharvesting, what we're focused on is just essentially hunting or removing more of those organisms than can be replaced through reproduction. So with fishing, the reason this is going to be overharvesting is because in most places throughout the planet, they're currently collecting more fish than that can actually be reproduced in those environments. So the overall fish population is decreasing. We saw something similar with the settlement of the Midwest and into the West, with the hunting of the American bison. Went from about 60 million to very, very limited populations extremely quickly, just because they were hunted extremely, extremely fast. Part of that also had to do with political and sort of racial reasons. The American bison was a critical organisms for the environment, as well as the Native American tribes that lived in that area. So one of the plans by the government, in order to kind of get the Native American tribes to, unfortunately, sort of, what's the correct word I'm looking for? Sort of fall under the control of the United States government, was to hunt the American bison and just essentially reduce their population, reduce their availability to the Native American tribes, make the Native American tribes' lives more difficult. So that was the hunting of the bison had a couple different factors with it as well. But again, it's still over harvesting because they were killing more of those organisms than could be reproduced. And then we see similar things with animals in the African countries. So a lot of the times this can be like big game hunting. Some people pay a lot of money just to hunt whatever those organisms are, those animals, just to, like, say they killed an elephant or whatever, rhino, whatever it may be. Sometimes they do it in order to collect certain pieces of those elements. So like the ivory from tusks. In other cases, there may be medicinal applications as well. But no matter what the reason is, it's still the same concept of, it's not a sustainable practice just because there's going to be we're going to be killing more of the animal than can possibly be replaced. And like I said, this can even kind of be a benefit in terms of predator or pest extermination. So also in the western parts of the country, I remember I spent a couple of weeks in Colorado and Wyoming while I was in grad school in Utah. They had different problems with coyotes. So a lot of times in those areas, they'll hunt coyotes to protect their livestock. But again, that's got other environmental issues. And then pest extermination, again, it can be related to the food production. We don't want pests destroying those crops. But with pest extermination, that can also lead to the extermination of other organisms that weren't intended for. So with bees, for instance, that I talked about, but a lot of times the pesticide used on various crops, in addition to killing that pest, is also going to kill the beneficial pollinators. So we can see a bunch of different practices are going to be unsustainable just because we won't be able to keep those populations at a viable amount. And then viable population, just again, remember, we didn't really talk about it in the lecture, but from the textbook, just looking at a population that will be able to sustain itself. If a population gets too small, over time, it's just going to continue to approach zero. And then with all of these different threats to biodiversity, I wanted to save population growth just for the end, because we've kind of seen how all of these relay into habitat destruction. Whatever the different threats are, they ultimately lead to habitat destruction. And that's the largest threat to biodiversity. But I wanted to save population growth to the end because we've already talked about it a little bit. But with this population growth that we've already seen over the past century or two, that we're expected to continue to see, albeit at a slower rate going forward, we're just going to see a worsening of these issues. So we're going to continue to see over harvesting. If there's more people, we're going to continue to see, we're going to clear more land. That's going to lead to more climate change. If we need to produce more food to feed these people, we're just going to see all of those different threats essentially just increase because we're just going to have more people now. Same thing with energy demands. If we have more people, we're going to need to provide more energy. We're going to, unless we switch to alternatives, we're going to be burning more fossil fuels, going to be creating more carbon dioxide in the atmosphere, furthering global warming. So with the population growth, we just want to kind of think about this could potentially, there are ways that we can kind of work around it. There are strategies that even as the population increases, things we can do to prevent this biodiversity loss. But if we continue to kind of just go about things as normal, go about things as we're currently approaching them, we're going to see everything just get to a worse point. But like I said, there are things that have been done in the past. There are things that we can continue to do in the future. It's not a completely lost cause. So even if that first part seemed kind of depressing, there are solutions, maybe not perfect solutions, but there are at least options for how we can approach these different types of problems and protect the biodiversity of the planet, protect all of those different organisms. And the main thing is going to be through legislation. So we're going to have the government, the different agencies within the government, create laws, create rules, and just establish a system that helps protect these different organisms, these different pieces of the environment. And then within the United States, at least, this occurred for the most part in the end of the 1800s. And then by the turn of that century, most states had some sort of hunting and fishing laws in place in order to protect some of these species. But with these protections, we should also note, this was started from more of the perspective of making sure that there was enough supplies, enough materials for the future. So it's more conserving for human use going forward, rather than actually protecting the environment, protecting those organisms for the sake of protecting them. So it was more of a human-driven reason rather than the ultimate good of just protecting the environment. But with that, we can kind of see the example of the American bison. So like I said, it started at about 60 million, and then over time, for various reasons, the population drastically decreased. And then they enacted some laws. They came up with a plan to kind of protect those, to reestablish it, to improve that population. And we can see over the past 100, and we're missing about the last dozen years or so, but we can see over the 100 years of the 20th century, we can see that population did start to recover. And then similar things have been done with different types of birds, for example. So wild turkeys, wood ducks, and snowy egrets are just a couple examples from the textbook. But with this process, the way we kind of go about doing it is thinking about those threats and how we can kind of protect against them. So in addition to limiting hunting or fishing, which is clearly going to decrease that population, we may want to restore the habitat if it's been destroyed, find some way to plant food or build shelter to support those organisms. In addition, there may be more hunting of a predatory organism if there's a lot of a certain predator in an area. But with these, we just want to come up with some way to think about how we can protect those organisms, how we can protect that ecosystem as a whole. But with it, again, there are, since everything is interconnected, we do have to really think about how we want to approach that. Because with the predator example, sometimes you may want to hunt the predator to protect an organism, but if you overhunt that predator, now you may see the protected organism get too high, and that can cause additional issues. So with these systems, they're extremely complex, and that's why it does make it difficult to find the perfect solution to how we can how we can approach these situations. But with the legislation, the biggest piece we have is this Endangered Species Act, at least again in America. And there's a couple different pieces to it. First, there's a set of rules, a criteria basically for identifying which species are at risk. And you can see at the bottom, there's a couple different labels there. So endangered being the worst, vulnerable being the, I don't want to say the best because it's not a good state to be in, but it's the least bad of those three options. So endangered is very close to extinction, threatened one step down, and then vulnerable again. But there's a criteria for determining which species fit into which of those categories. And then there's a planning process that occurs to determine how they can support the recovery of that organism. And with this planning, it's a complex issue, like I said, because there's a whole bunch of different factors. One of them often includes money. Well, not often, it always includes money. If there's not enough money to do it, it just won't happen. But two, it also involves typically the community and often private individuals sort of making an agreement to help protect whatever that organism is. So for example, your textbook mentioned, forgetting the name of the company, but it was a paper company that allowed for where they were obtaining their lumber. They allowed for a population of a certain type of woodpecker to be introduced into an area with damaged trees. So it was an area of trees that they likely weren't even going to use anyway. So they were able to make a deal that allowed for the woodpecker to be introduced in that environment, and then the company was going to do a couple other things to help protect that bird. But in return, the company got goodwill, so it got public support, public goodwill just from obviously helping that organism. But it also was able to use different pieces of the forest to then get the lumber. So it was an advantageous agreement for both sides. The company still was able to do their thing, was still able to make their money, but they at the same time were able to help protect an organism, help protect that ecosystem too. And then the final piece of these is the enforcement. And this is going to be, I don't know if it's the most critical, because if we don't have the planning, it doesn't really matter. Like, we need to have the actual plan to help protect these, but we do need the enforcement. Otherwise, there's really no teeth to these laws. And this is one of the issues with the EPA a lot is many of their thresholds for acceptable contaminants and things like that aren't actually laws, or aren't actually limits that they can enforce. So there's really nothing they can do about it in a lot of situations, or not too much they can do about it. But with the Endangered Species Act, that's not the case, and there is actually very strong enforcement of this, and this helps protect those different species, those different habitat that are endangered. That's why if you were to kill an endangered species and get caught for it, there would be either a fine or I don't know exactly the punishment, but it would be a fine or jail time or both, depending on exactly however that played out. But with these plans, like I said, they often involve sort of negotiating with companies or private individuals, because a lot of the times they need a space for these organisms. They need some habitat in order for these organisms to recover, replenish, and then ultimately get back to hopefully their original levels. And what this is called is sometimes pop-up wildlife refuges. So similar to the example with that paper company and the woodpecker. But other examples of plans include just restoring whatever that habitat may be, buying habitat areas. So a similar idea to a pop-up, kind of just purchasing an area and making that the new habitat. In other cases, like with the, I think it was the gray wolf, I believe, was introduced back into the forest where it lived, and then captive breeding programs are going to help improve populations just by ensuring reproduction occurs. And that could be things like zoos, or it could just be other sort of areas where these organisms are monitored and watched. And then with these different types of recovery plans, we've got a couple of species that we want to focus on, just in terms of how we think about them and the role they play, because some of them play larger roles than others. So the Keystone species, we've talked about a little bit in one of the previous chapters. These are going to be extremely important. So we've looked at food webs and seen the interconnected nature of these types of ecosystems. And if you remove any organism, you're going to be leaving a hole in that ecosystem. But with the Keystone species, that hole is just going to be sort of larger than normal. So it's just going to be an extremely important species for whatever that location is. Doesn't necessarily need to be The apex predator doesn't need to be the thing at the top. Often it is considered that. So things like sharks are often considered keystone species in their communities, but even microorganisms in other communities are considered keystone species, because if we remove those, now the rest of that ecosystem is going to really start to crumble, or at least really have to change. Indicator species as well, we've talked about. So those are just going to be species that are very sensitive to a change in a certain environmental condition. So trout, for example, need extremely clean water. So if the water starts to be polluted, you start to lose the trout there. That's going to be an indicator that the cleanliness of that water has decreased. And then the final two we haven't talked about yet, but umbrella species. These are going to be species that need a lot of land in order to survive. They need a lot of land to operate, to hunt, and just live in general. So protecting the umbrella species is important, because by protecting their habitat, by protecting that large amount of space, you're not only protecting that species, so things like gray wolves that I just talked about, or tigers, you're going to be protecting everything else that lives in that ecosystem. And then with the flagship species, this is kind of a different idea in terms of, this has more to do with the perception that people have. So things like giant pandas are considered flagship species, because these are animals that are going to be sort of charismatic. They're going to be animals that can get sort of an emotional response from people. They're going to be animals that people may care about more than certain other organisms. So a lot of times these are used to motivate public interest, and to get people to actually care, to actually act in order to protect the biodiversity. And the reason for it is, again, things like pandas, people often think they're cute. So you can see this one just kind of smiling and waving. So with things like that, those, like I said, charismatic animals are going to be the ones that people are just going to have an emotional response to, the ones that they're going to feel sort of a connection to, and the ones that they're going to be more likely to care about, more likely to want to protect. But again, all of these species are going to be important because of the interconnected nature of their ecosystems. It's just obviously humans are going to be flawed, going to have different preferences for different things. And I can certainly understand why people would think this little panda is a cute little guy. But in addition to kind of just the legislation, there's a whole bunch of other ways we can protect this biodiversity. So the legislation, obviously on an individual basis, we can't really influence or change. I know a lot of you are running start students, so you may not be of voting age yet, but when you do get to 18 and older, when you do start to be able to participate in elections, one way you can at least kind of influence this part is by voting for candidates that are interested in the protection of the environment, interested in conserving the environment, protecting the biodiversity of the planet. But also what we can do just either individually or as a whole, because these are going to be a collection of different things. The fossil fuels, we need to switch from fossil fuels to green energy. So one of the later chapters will focus a whole bunch on the different types of energy that are available in different locations, and sort of the pros and cons of each of those. But if we switch to greener energy, we no longer burn those fossil fuels. We're not going to see global warming continue, or at least hopefully not continue at the rate it is. Hopefully we can kind of get it back under control. That'll help with the habitat destruction, like the polar ice caps. Wildfires would hopefully stop occurring at quite the frequency, things of that nature. Buying local and eating less meat just reduces your carbon footprint again, so it's going to help with the global warming. Same thing, conserving water. So a lot of these are just sort of reducing what we're putting out into the environment, or reducing how much we're using in general. But other things like habitat protections, so similar to the umbrella species, the reason that those are important or so useful is because if we protect those, we protect the large amount of land they need. We're protecting so many other things. So that's why people often suggest habitat protections rather than species protections. And another reason for that is because those species, the ones that get a lot of money tend to be those charismatic animals. So the panda bears and things like that, other types of bears as well. But with that money, you're really only protecting that specific species. And a lot of time that protection winds up being in the form of those animals living in zoos and zoos and other environments like that, rather than their natural homes. So when you're actually protecting those organisms, what actually can occur is the continued destruction of their original habitat, because there's nothing really being done to support the rest of their home environment. We're just kind of focused on that organism in the context of a zoo or some other similar situation. Gap analysis is, if we think about the protected lands of the United States, the national parks and things like that, those are good environments in terms of protecting the species there, because you can't really do any hunting and they're just protected species. But then there's whole bunches of land in between those national parks, which makes those national parks similar to that island example, where they're kind of just their own separate entities. And in that case, it leaves them vulnerable to losing that biodiversity. So the gap analysis is kind of identifying those national parks and those other protected areas, and then looking to see in between them, what are the most important non-protected areas, so that we can focus our attention on those, focus our attention on preserving the biodiversity there. And that kind of serves as a link between those different protected areas, serves as a sort of overarching aid to the entire environment. And then a couple other ones: improved pest management decision, protecting the bees go hand in hand. We'll talk about that one more specifically later on, but pesticides negatively impact non-target organisms, non-target areas. So if it just gets in contact with something that wasn't intended for, or gets to a location it wasn't intended for, there's going to be negative consequences related to that. So one way we can improve or protect the biodiversity is by making smarter pest management decisions. And that can include part of my graduate research, which was figuring out exactly how pesticides behave in the environment, so that we can spray them more effectively, spray them at better times, make sure we get better protection with less use. But also just using alternatives. So you don't have to use pesticides. There's different crops that you can use, different species that can be introduced to protect your crops and things like that. So there's a whole bunch of different options in terms of protecting the environment. Later on in the course, we'll continue to go through some of these more specifically, look at some of the details related to them. And this isn't by any means an exhaustive list. But if you have any questions on these specifically, or have any other ones that you want to discuss, please just let me know and we can look at any of those.